All right, so I think we're gonna start now.
Hold on, let's see who else there.
Yeah.
So we have Azzy, we have Carter and Colton. That's who's there remotely. Is that it? As far as remote?
Yeah, I think so. Like, I don't think we had like 2 more people yesterday, but I don't think they're going today.
So it's 1:03. Let's give 2 more minutes for everyone to join in.
Okay, all right. All right, so we will be starting now. I think we've waited long enough. Yeah. Yeah, welcome everyone to day 2. So all right, so Java compiling and running code. After a Java source file, in this example, we'll be using just like test.java for as a name. So after it has been created, it needs to be compiled. So the compiler will compile the code in that file, and this generates a bytecode file, which in this example will become test.class. This is done using the javawk command of the Java Software Development Kit or the Java SDK.
So at this point, we'd just like to ask, I know some of you have had experience with Java, but have you used an IDE or have you had experience using Java command line? Like, have you ever typed that command like Java and then C and then the name of a Java file? Has anyone ever done that? Okay. So the reason you may not have done that is you probably started learning Java with an IDE. So IDE is like Android Studio or IntelliJ or Visual Studio Code. So what happens there is there are menu items which you click on, like when you say compile, that is running Java test.java on the file where you hit compile. So all that's happening behind the scenes, but you may not be aware of that. But it's important to understand that when you compile Java files, that command gets run on every single Java file that you have in your whole project. Okay. And if you see there's a build directory, you may have by chance gone and seen the build directory. After running the compilation on all the Java files, if you go look at the build directory, you'll see that there's a .class file for every single Java file that there was in your source. And yeah, you can proceed at this point and let's talk about the next piece again.
All right. So now that you've done this on this bytecode file, the test.class, it can be executed on any operating system, but you can't run it like just on the operating system. So to actually execute it, like execute the byte or the test.class file, you need an interpreter, which will convert the bytecode instructions to instructions for the operating system to execute. So you would use this command, Java test, and then it runs the bytecode test.class. And the JVM or Java virtual machine is the interpreter that can run this bytecode generated file after compilation. So by interpreting it into it, yeah, it does this by interpreting it into machine level instructions for the operating system.
So what is important to understand here again is whenever you write code and you run it on a computer, it ultimately is going to get converted into what is called machine code, because that's what will actually work with the processor, the memory, and things like that on the system. Now, you may have run a .exe file. In that case, it is running directly on the operating system. But if you used a Mac, a Linux, and a Windows, you might remember that an exe file only works on Windows. You cannot run exe files on Linux or on Mac. That's because the exe file is created specifically for Windows. One of the really neat features about Java is you can write it in one place and then compile it. but then you have the ability to run that across any operating system. And the reason for that is this thing called the Java virtual machine. So if you remember, there were instructions to download Java and install it. That is one of the examples. And in fact, when you run the installer for Android Studio, it is also installing a Java virtual machine on your computer. So this Java virtual machine is an application that sits there. It's a piece of software that sits there between your Java code and your operating system and allows you to execute the bytecode. It's called bytecode because when you compile the Java file, you literally are getting a file which is going to have hex data on there. It's not something you can read. Like it's not English words or words that would make sense because it's already in byte format. And that file can be executed on the JVM. So you have a different kind of JVM for Mac, a different kind of JVM for Windows, and a different one for Linux. But once you have it installed, the same .class file can be run on any of these JVMs because the JVM will take care of converting that code to instructions that are specific to Windows or instructions that are specific to Mac or instructions that are specific to Linux. So that's why Java is well known as write once, run anywhere. Okay, you write the code once and it's applicable to any operating system because the JVM or Java virtual machine will take care of that adaptation between your code and the operating system specific machine instructions. So that's a very important part of part that you should understand about Java. And one more thing, one more reason we have this information here is for you to clearly understand that when you're using an IDE, you may hit compile and you may select run. But when you do that, there's a whole lot of things that are actually happening behind the scenes that are happening to the files that you just wrote. Running of Java, that is compiling it. And then once you have a class file, test.class file, when you click on run, it is going and running the command Java on whichever specific file needs to be run. So please understand this because when you use the IDE, it is easy to not know this. But as a person who's learning Java and working with Java, it's important to understand that this is happening behind the scenes. And so in addition to that, at this point, let's see, we have a few members who've joined, a few participants. How many of you, is there anyone here who has never worked with Java? Please don't hesitate to let us know. I mean, this is a camp for everyone. So we want to, okay, so we have one person. And I know Colton and Carter, you guys were just starting to learn also. So that is good information. So as part of this camp, we are not focusing on teaching you Java because there's so many courses, so many easier ways to learn Java. What we are focusing on is getting you set up so that you can use Java for FTC. And we are going to be, in a few minutes here, we're going to start working with a lot of code. And as you see that, it will start making sense. But I would strongly suggest take a Java course before your season starts. You have 3 weeks left for your season. Take a Java course. There are some Java courses which are meant for younger people to learn quickly and easily. And at the last 2 pages of this slide, PowerPoint slides, which will be shared with everyone who's attending, you will find a lot of resources. One of them is Java for FTC. It's a PDF file. Strongly suggest learning, going through that if you have zero experience with Java, because that will quickly get you set up with just enough Java knowledge to be able to use it for FTC. So with that, don't hesitate to ask questions as we go through. We'll be happy to answer that. Let's see. So we have everyone I think we were expecting, and we have everyone here. Okay, so at this point, you can move on.
Okay. All right, so next is Gradle. So basically when in the most common processes in building any software include compiling the source code and packaging that compiled output to a compressed format like APK, which is like an Android package. And then there's also other ways like jar, tar, and zip. Zip is pretty common. You've probably seen that before. So we might also perform some other tasks like publishing the artifacts to some repository or transferring the APK to the Android device. If there's no build tool to automate this process, then we will need to perform all of these actions manually, which would be slow and have chances of human errors. So basically, the build tool we're talking about is Gradle, and it's the build tool used in the FTC SDK to automate all of these processes.
So it is important to understand that there's this software called Gradle, which is being used along with Android Studio. Now, on the right-hand side, you're seeing these different files, build.common.gradle, build.dependencies.gradle. There may be some times when you'll need to go and modify those. For example, if you want to use a third-party library or a different library which is not already included in the FTC SDK, then you will need to go there and add those dependencies. Typically, when you're trying to add a library, they will give you the instructions, but you need to understand what is happening. Why do you need that? So Gradle is what runs the command. So when in your Android Studio, you click on build, it is building all the, just like we showed in the previous slide, it's running Java on all the Java files. That is happening because of Gradle. Gradle is sitting there and making that happen. And then when you, as you'll see shortly, when you connect your robot, your control hub to your laptop where you're running Android Studio immediately shows you this new device to which you can upload your application. So it'll show you the control hub. I think it shows up as a robot controller or something like that. But at that point, when you click on run, what is happening is it is building this, building all the Java files. It is packaging them together as an APK file. APK means Android package. And if you have seen Android phones, all these mobile apps that you download, those are APK files. So when you go to the Google store and you download a new application for your Android phone, it is an APK file. So you are creating a new APK file in Android Studio and downloading it into your control hub. And as you all know, the control hub is just like an Android phone because that's the operating system that it runs. So when you click on run and the creation of this APK file, how does Android Studio know to do that? It's because of all these build files, the Gradle build files that have been put together. Now, most of this is already in place in your FTC SDK. What you will be doing here, if at all, is adding some new dependencies. Or if you start using, like, was it for TensorFlow? Can you guys remember some examples? Roadrunner, yes. So Roadrunner, which is one of the third-party libraries that allows you to work with autonomous very easily. When you add Roadrunner, which is the third-party library, you need to go into build dependencies and build Gradle and make some changes. So that is a perfect example of where this slight knowledge of how Gradle is used will be useful. So just remember that Gradle sits between your IDE and generation of this APK file and downloading it to your control hub. So it's doing all the work which you don't see, but that happens when you click on the run icon in your IDE. Any questions from anyone so far? Has anyone worked with Gradle or any such build tools before? You may have heard of Ant. Ant is an older build tool. Gradle is a new one. And then you may have heard of Maven. That's also fairly new, but I think Gradle is newer than Maven. These are all build tools that are serving similar purposes. Okay. All right, if we don't have any questions at this point, actually, let me go back and we should have probably asked this right at the beginning. Did anyone have any questions based on what all was covered yesterday? Okay, if not, then we'll continue on to the next slide. I know we won't be teaching Java, but we think that it's in the best interest of all the students to quickly get a refresher on how object-oriented programming works, because once we start talking about the code and how you're instantiating classes, we need it to make sense to everyone. So please stop us and ask us questions if after this slide and the conversation, it's still not making sense when you see the code. Okay.
So object-oriented programming involves classes and objects along with their attributes and methods. Java is one of the programming languages that uses object-oriented programming. So as an example, in real life, an apple is an object and it's an instance of a fruit, which would be the class. So the apple has attributes such as weight and color and methods. And methods are what can be done by the fruit, such as grow and rot. So if Jill, an object of class person, is eating the apple, then eat is a method that the class person has. So a class is like an object constructor or a blueprint for creating objects. In the following illustration, you can see the difference between classes and objects. So like the class would be fruit, and then the objects in the class are apple, banana, and mango.
So here, when you say fruit, it's like a common possibility, right? It could be any of these actual fruits. It's just a way of defining that it is something that you eat that is probably sweet or sour. So a fruit is that blueprint. It's that class. And then when you talk about an actual fruit, that is an instance of that possibility of that fruit, right? It is an actual fruit. Apple, banana, mango. These are all examples of actual fruits. So those would be objects. Now, same thing if you talk about in terms of persons, which was the other example. Now, person, think of it as a class. Now, each of you is an object because you are a person. You are an instance of a person. You're what a person looks like. So each of you is an object. And the word or this concept or thought of person is the class. So this is very important to understand in your mind, because what you do is in your code, you will be writing classes. You're writing what a class will be, but then you will instantiate those pieces of code and use them in other pieces of code. So to be able to really understand that, it'll start making more sense as you see actual code. But remember these examples, because these will help you understand what, when we say class and then object, what are we really talking about? Okay. And talking about methods, well, let's talk about attributes. So attributes are qualities of these objects. Now, for example, when we talk about an apple, it is a specific type of or a specific instance of a fruit. But then each apple can have its own weight. Each apple could have its own color. And then if you're talking about persons, each actual person could have a name, they would have an age. So these are all attributes about that person, about the instance, about the object, right? And then in the class, you would have just indicated, yeah, persons can have age, persons can have a name. But the actual value of those attributes will come to life only when you talk about a real single person. If you're talking about persons, age and name are just variables, which can hold values. But they will hold values only when you talk about actual people, right? When we talk about Jill, yeah, Jill is the name of that person. She may have a certain age and things like that. Now, so with that much of understanding about attributes, let's quickly talk about methods. So methods are what can that object do, right? Now, a person can walk, they can talk, they can study. All these are their abilities. So each of those would be like methods of that object. Now, when we start looking at the actual code, you will see that every class has some methods and every class has some attributes. We may call them variables, but those are all attributes on that class. I know it feels a little vague, but we'll jump right into some code now and it should start making sense. But does anyone have questions from what we just spoke about? Okay. Now, as you those of you who are in the middle of learning Java, as you continue to learn Java, you will come across more and more of references of object-oriented programming. And so definitely make sure that you read and understand the nuances of how object-oriented programming works. It's just a way of thinking. That's really what it is at the end of the day. The way you are supposed to think to be able to work with object-oriented programming. Okay, you can take it from there.
All right. So, yeah, moving on to the next slide. This is, you guys will actually start to be able to do stuff like hands-on stuff now. So for, first of all, you guys all need to open, Android Studios. So wait, let me just make sure I'm sharing my full screen really quick. Yeah. All right. So basically, yeah, this. Yeah, so you guys should have a screen that looks like, where's the
So let's have everyone open Android Studio first. So Colton and Carter, I know we were in the middle of getting your GitHub set up, but for the purpose of what we are doing right now, it is okay not to use GitHub because we are just going to be running code at this point. So maybe during the break, we'll work on seeing if we can get that GitHub figured out. If we can do it, then we will have a separate session with you guys and get that done later on after this camp. So those of you who are, actually, I think we should ask this question. Vihan, you were not here yesterday, is that correct? So Vihan, you can unmute and talk if you want, or if you want to send a message, that's fine too. Okay, you were there for part of the meeting, all right. And the reason we ask is, did you get a chance to follow all the steps right till the end, which is at the end of the steps, I think everyone had downloaded the FTC SDK controller and they had pushed it to GitHub. Now the pushing to GitHub part, if you haven't done that, that's okay. You can still continue to do what you're doing today. But you need to have that FTC SDK controller downloaded. That is important. So what I will ask is each of you open your Android Studio right now. And then do you want to go through the steps of how they would open the?
Yeah, sure.
Yeah. So
basically, just close this. So wait, I need to like download the zip file again. I need to download a new zip file.
No, you can just show the same one. You don't have to actually hit OK after selecting it. Just show them the steps that they would follow. So you would go to,
okay,
exactly. So you would close that.
Basically, first, when you open Android Studio, you would see this screen.
They may not have anything in the list.
Yeah, you guys, your list will probably be empty, but you have to click open. Yeah, and then it'll take you to your like file directory. So then you have to find that zip file which you unzipped from yesterday.
Not the zip file, but the unzipped folder.
Like, yeah, you have to find like the unzipped folder. So for me, that's like in here. Yeah, and then you would click on this. So that you would click on your FTC robot controller 8.2, and you just click open, and it should open a new project, and your screen should look like this. And it will take like a minute to load because like the Gradle files need to sync.
So this could take, depending on your internet speeds, it might take 2 to 3 minutes, but please follow what was just showed. And we want to have each of you indicate that you're able to do this before we can proceed. So please raise your hand once you're done, or send a message once you're done opening this. If you're seeing that word loading on the left-hand side, then we'll just wait for that to complete.
Oh, so Colton and Carter, you guys said you don't see an open button. Okay, that's
Maybe.
interesting.
So, Colton and Carter, if you want to share your screen, we
Yeah,
can quickly see what's going on. But Vihan and Ezzy, if you both are able to do that, let us know. Can you go to sharing settings and allow
yeah.
participants to share?
Okay, all right. Vihan said Android Studio is currently installing. Okay. All right.
Okay.
Did you just start installing it or has it like been installing for a while?
Okay, yeah, so that's fine. Vihan,
Yeah.
just let us know once that's done and we'll continue from that point.
Yeah.
And Vihan, parallelly, you could also download the FTC SDK controller
Yeah, I'll send a link for that.
if you haven't already done that.
Yeah, so Vihan, for you to download it, so basically you want to click on that link. And then in the, like kind of like not really the bottom right corner, but just like the right side of your screen, you'll see like a green V 8.2 like under releases. You'll see V 8.2 and it should say like latest. So you just click on that. And once you click on it, click on the source code zip file and just download that. Or well, all right, if you're on a Windows or Mac, then you want to click on the source code zip file. But if you're on anything else, you want to click on the tar.gz.
Okay, so now let's see if Colton and Carter is able to share the screen.
Yeah. You guys.
So Colton and Carter, if you want to share your screen. Oh, they say we found the open button, but we have the file on a different device.
Oh, okay.
Oh,
All right.
okay,
In that
so-
case, just
yeah.
do what Vihan is gonna do. Just like, oh yeah, I'll send you the link. Yeah, I'll send you guys the.
So Rohan here is sending the link to you both also, Colton and Carter. If you can
Okay.
please go and download that file and then unzip it.
Yeah, so it's like the same steps as you did yesterday. And just let us know when you finish downloading the SDK. Is everyone in person at is their screen like at their wait, let me look my notes. So okay. All right. Is Isha and Arjun, does your guys' screen look like this? You see this? Huh? Arjun, does your screen look like this? Yeah. Okay. Colton and Carter, what like I'm not really sure what you guys mean when you say you clicked on the Android Studio link. Like, is that like the download link or like the link that I sent you? Oh, okay, all right. I see. So, all right, if you open the link that I sent you, what you want to click on is like the V 8.2, like it's like green and there's like a latest. It says latest, it's right under releases. So click on that. Yeah, I don't think you need to click on Android Studio. Just click on, oh yeah, I'll share my screen and show you guys. All right, here, yeah. So basically, this is like if you open the link, you should be on this screen. So you just want to click on this. And let me know in the chat once you've clicked on this button. Oh, okay. Um,
See. So Ezzy, if you are unable to find it, you can still download the release again, the FTC SDK controller app. So you would follow the same instructions as others, if you can just send it to him.
yeah.
So all you need to do is download it and then actually send it to everyone. So just download it and then you can unzip.
Yeah, so, all right, so yeah, Colton and Carter, you guys said you clicked on it. That's good. So then you just want to download the source code zip file. Wait, yeah, they download that one.
Yeah.
Yeah, they're on like Chromebook. Would they still download that? Or something?
Yes.
Okay. All right, yeah. So yeah, Colton and Carter just download this one. So yeah, you just click on it and it'll start downloading. And then for Eze, do you know how to download the SDK or do you want me to show you? Okay, all right, good job, Colton and Carter. You guys are done. Um, yeah, and Eze, just like let me know if you need help with it, and if you don't, then just send a message.
So meanwhile, Colton, Carter, and Bihan, what you three can do is open up Android Studio and then see if you can click on the open button and browse to where you just unzipped. Oh, or if you haven't yet unzipped, please go ahead and unzip that file which you just downloaded. And then select the unzipped folder and hit open in Android Studio.
All right, so Eze, you messaged me that you need help. So basically, if you open the link, you should be on this screen. So you just want to click this button, the V 8.2, and it says like latest. And then once you click on it, you just want to download the source code zip file, and you should be good. All right, and Eze, just let me know once you've started downloading the SDK. All right, yeah, I'll show you one more time, Eze. So basically, this is like the screen you should be on. So you just want to click this one right here. And then once you click on it, you want to download
Wait, ask him if he
source
got
code.
that saved.
Oh yeah, Eze, are you on this page yet, or are you still on the previous page?
So break up, like, just go somewhat before- even- just take your time. Perfect.
figure it out.
So,
So as a, you're in this screen right now, correct?
yeah, so just click on this one.
Okay, so as a, yeah, you click on that
Yeah.
V 8.2, and that should take you to the next page.
Okay, I did that.
It's not.
All right. So now, download this first code.
We can hear you. I downloaded it.
Okay. So once it's done downloading, you can just unzip you can just unzip the file, and you can do the which I showed you earlier, where you actually open the whole video in here, and you click on open. Yeah, click on open. Just like go to wherever you had that file. Yeah, you had the unzipped file with it. It's like here, and then you would just click on like this, and then you click open from the bottom like this. Yeah. All right.
Okay, so Vihan said the build has completed. That's great.
Yeah.
Okay. So Vihan, you're ready for custom code to be added. That's great. So let's just wait a minute or two here for others to reach the same state. So I think Colton and Carter are both doing this on two separate machines now, correct?
I think so. Yeah.
So Ezzy, can you please update us on where you are? Okay, that's good to know, Colton and Carter. So Colton and Carter, once both of you have had a chance to download the file, then please unzip it and let us know. And
It is unzipping.
it is unzipped. And Ezzy, can you please let us know what point of the process you are in?
It's unzipping the file.
Okay. Yeah, that's good.
You need to at least find it for me. Come on.
Where was I?
So Ezzy, I don't know if we got did we get a response from Ezzy? Okay.
Remember you said, yeah, they said they're like unzipping. the
Oh, they're unzipping. Okay.
So, Colton and Carter, where are you guys in the process right now? Do you guys like have the file unzipped, and are you opening it? Okay, all right, that's good. Yeah, so you guys are trying to unzip. All right, that's good.
Don't like this.
Oh, sorry, what was somebody saying something? All right, so
So-
Colton.
Yeah, it says it's different on the other computer. So are you still able to unzip it, or did that not work? So Carter, I'm assuming it's your laptop, which is the other one. or the other computer? If so, can you please let us know when you tried to unzip, did it work? So on the iMac, if you just double click it, it should unzip it immediately. You can just double click it. So it's not Carter's computer, okay.
Yeah, the webcam didn't work because, they changed, like, I think they updated the layers from school. That's why they didn't repairs.
No, wait a minute.
Like that.
You don't want iCloud.
But you guys are figuring it out.
Okay, so, did you talk to them about unzipping on iMac?
Yes.
Okay.
So Vihan has unzipped and opened it in Android Studio. Ezzy, can you please provide an update? Were you able to unzip and open it with Android Studio?
I haven't unzipped it. I'm trying to do that right now.
Okay, and this is for Ezzy, is that right?
Yes.
And Colton, you are on the Zoom session with your own Chromebook, correct? Okay, so Colton, were you able to unzip and then have you been able to try and open it with Android Studio? Okay, so I got the message. I think it worked. Is that for the iMac or is that for Colton's computer? iMac, okay, great. Now, going back to Colton's computer or Chromebook, has that unzip completed and is Android Studio able to open that up? And that brings me to the other question. On the iMac, do you have Android Studio open? Okay. Okay, so on the iMac, if you can please try and open up the folder just like was shown. At that point, I think we'll have everyone in the middle of either unzipping or trying to open it with Android Studio. So we have a few people here in person, and they have all opened the files up in Android Studio. So we're going to hopefully get this in a few minutes so that everyone can start progressing at that point.
You get the con. Chemistry. You get the con. Oh, the one with symbols on it that aren't ours. Oh, wait, it will detect the dots. Oh, we detect the dots. No, look at the thing. Look at the screen. Oh. Oh, nice. This is the base. No, this is the yeah, it's copied out of there. But how do you upload a custom part? We're not doing this. No, I know, but if they want to do that, because this one doesn't pull from a model file. No, yeah, I saw that. Actually, I don't know where it is. Maybe it's not the license. In assets or storage, I'm not sure. It's not writing. There's no T1 mode find in the file. And it's still what it's natural and it's so yeah.
Let's see if the default object is going to be initialization else.
So Eze, have you been able to unzip the file yet?
No, because I have to get something for it.
Okay. Just let us know when you finish it.
Okay.
So what we're going to do is at the end of the hour, we'll proceed, just in the interest of the fact that there's few who are waiting and have opened up the folders in Android Studio. But all this is being recorded, so definitely you'll have a chance to look through and go through that. So I see it failed to open. So if that was on Colton's computer, Colton, could you please share your screen? That'll really help us figure out what the error is and what's going on. Guys, can you come and work here? Because one of them had a failure.
Okay, all right. So, oh yeah, let me stop sharing so that you guys can share. Yeah, you guys should be able to share now. Oh,
Okay,
okay,
yeah,
I
if
see.
the-
Oh,
if the
okay, I
iMac
see.
does not have
That's
Android
right.
Studio, then
No,
downloading
no, it
Android
should-
Studio would
She
be
said on
needed.
the Chromebook they don't have Android Studio. No, I
Oh,
think
on the
that's okay.
Chromebook.
That's why you guys switched over. Okay, that makes sense now. All right, so you guys won't be able to share your screen, kids, on a different device. Is there any way you guys can join the meeting on the iMac?
And also, just to be clear, okay, all right, that's good. So yeah, if Android Studio is not installed, then we won't be able to progress on that particular computer. So what I would suggest then is, let's go over to the one that has Android Studio.
Yeah, that's why they
which
switched
is
to
the
that.
iMac.
Yeah.
And then you can join the meeting from that iMac. And that way you'll be able to make progress, but you'll definitely have the recording and you'll be able to follow those steps on the Chromebook later on. And somebody said Android Studios when they were talking, it is Android Studio, so it's not plural.
Yeah, so I see you guys joined on your other computer, so you guys should be able to share, I think. And also, I'd suggest you guys just share your like whole screen rather than sharing like a single app, because that'll make it easier like switching around. You don't have to stop sharing and reshare.
So let's just make sure we have all the status is correct. So Vihan has opened it up in Studio and is waiting for the next piece, as is everyone else here in person. And then Ezzy, you are in the middle of trying to unzip. And Ezzy, what computer are you on?
They might need to be there because they said they need to get something.
I'm trying. I have to buy it and process it there.
So I'm downloading.
and download it. WinZip.
Sorry, and this is, so on Ezzy's computer, you're still trying to unzip it, correct? Do you have a,
Yeah,
you have a Chromebook or something?
I have
else?
a Windows,
You have Windows, okay. So if
but I
you,
have to download it.
if it's Windows, one easy way to unzip it is you can just double click on the zip file. It'll open it. You copy the folder, you go out of the zip file and then you paste it. That's one way of unzipping it without having an unzipping file.
Oh. I try that.
WinZip, yeah. So, I thought they were still installable.
Wow.
This is not the time to do this.
And Colton and Carter, you both are working solely on the iMac now, correct? So both of you together are working on the iMac. Okay, great. So were you able to unzip it by just double clicking it?
Wait, where do you paste it?
Okay, so when you double click it, so if you can show the Finder window. Oh, this is Amelia, which is on the iMac, which is very important.
I think this one.
Okay, so you already have that FTC SDK controller
Yeah,
created. So if you click on that second folder there, it says FTC folder. Oh, sorry, you're already in there. Okay. Okay, no, that is good. That is good. You can leave that there.
This
Now,
I
if you
could
move over to the Android Studio screen. So you need to drag that into applications.
put too many things.
You drag Android Studio applications
Oh, I
folder.
can see.
Is that already done?
Yeah, you guys already have it down.
Oh, yeah,
right?
they're already
Yeah.
open. Okay,
All right.
sorry.
So
So that is Finder window. So you can, let's see, so if you can load whatever you have open and then open the new one. So I don't mean close the window, you'll have to select the, Ron, can you please come in and open Android Studio here and show them how to close that? Oh, at least you say it out.
wait, let me just. I can.
So one of our,
Yeah.
so Rohan here is requesting remote control, so he can check if you can approve the remote control, he'll be able to get that open.
So basically,
I think they're giving control, so we can.
oh yeah.
So I think you have to click on that. It's still, once it's toggles. You can click on the button where Zoom is shown.
Yeah.
It's still not toggled to on.
Yeah. Like click on the little white dot, like on the Zoom. It's highlighted. Click on that little white dot.
Yeah, it's still not toggled.
Yeah. Like. All right. Basically, do you see? All right. You know how like Zoom is like highlighted? It's like blue, and then there's like a little like white dot kind of at the end of it on the right. Just click on that white dot.
Yeah, perfect.
Yeah, there you go.
Okay, with
Okay,
that,
should
if you can request access now.
I should be Yeah, there you go.
Okay,
Alright, I am now able to, alright. Yeah, okay, alright, that's good. It should say that future Martians are controlling the screen. So now.
let me close that, and you
close
can
that.
close the other window where they dragged. Yeah,
Yeah.
just close that.
Okay,
then-
so
okay.
basically, what you want to do is click open. Yeah, and then where is it?
I think,
Is it
check on the downloads.
downloads? Alright. I didn't see
Where-
that there.
No, it's up there. I don't think they have.
Yeah, is it? I think it's this.
Yes,
Yeah, so then you click on this and you just click open. Yeah, there you go. And now it'll take a little bit to load, but yeah, there you go. You should be good to go now. So, all right, I'll
Perfect.
stop controlling your screen. Yeah, there you go.
so you can take control back now. Okay, all right, so Colton and Carter, if you let us know once the iMac has finished loading it, we can then proceed. And also, Colton and Carter, do you both have the electronics available to run locally, or are you just going to?
Yeah, like, do you guys have the control hub and driver hub, all that? Okay, all right, that's good. Yeah.
Yeah, so if you want to have that handy now and ready and powered on,
Yeah, and you guys will also want a motor and a servo.
so yeah, I think we were going to talk about motors and servos.
Yeah, so yeah, a motor, servo, and then if you have a controller too, like a Logitech controller, like if you guys have one of these, you should get that too, because we'll be using this. Okay, good. Do you guys have like a full drive base built up? Alright. So alright, when you guys say it's okay, last year's, okay, nice. What kind of like drive base is that? Do you have strafer wheels on it or like Mecanum wheels on it, or what kind of wheels do you have? Okay, alright, that's perfect. That's you guys will be able to like do a lot of coding then. That's good. Alright. So have your guys's yeah, so you guys are getting the electronics ready, and has your Android Studios has the Gradle finished building? Okay, all right, that's good. All right, I think we're ready to move on then. Yeah. All right, nice. So, yeah, I'll just share my screen again. So let's go to presentation. Shoot. Okay. Okay, so, yeah, so this is where we were downloading code for the first time. So basically, Colton and Carter, you guys are the only other ones who have the electronics. So, basically what you need is you need a cable that like a USB-C cable that will connect to the control hub, and just a USB cable that will connect into your computer. So I'll get one of those to show you guys. We need to show them how it's done.
So everyone here also. You can swap in.
So, I'll just take this right here. Wait just a second. Wait, hold up. Wait. Okay, all right, yeah, that's good. You guys have USB-C cable. Okay, that's good.
And they have a
Okay, there we
mechanism.
go.
diagram.
Yeah, so. So yeah. We have. Alright, so we have this slide. So, alright, yeah, so basically, we'll just do like a live demonstration with the USB. Alright, so I'm gonna stop sharing. That way you guys can see the video like in full screen. It's like, it's like, oh yeah, wait, why does our video keep turning off? Yeah, that's kind of weird. Okay, all right. So if you guys can like, yeah, if you guys just like look at our screen, yeah, yeah. I mean, actually, spotlight, yeah, there you go. Okay, all right, here you go. So basically, now, looking at the screen, basically we have this cable, this orange cable. So there's a USB-C end, which is this end, and a USB end, which is this end. So you want to connect the USB-C end into the
Okay,
controller.
before that, so this, just to mention, at this point, to run these samples, all you need to have in place is your control hub with a battery connected. Preferably with a switch, but you don't need any of these other cables to be connected at this point.
They have been like last year.
Okay. So if you're using last year's competition robot, then it's okay to leave everything else connected.
We have some comments. So, all right, Colton and Carter, you guys said your driver hub has been charging all morning, but you can't turn it on. Okay, yeah, we've actually had this issue before. You just kind of have to like keep trying, just like keep hold the power button for like 10 seconds or so, like it should turn on. But yeah, just like keep trying. It should eventually work. But yeah, we've had this issue too. It's pretty annoying. Yeah, and Vihan,
So we had a question come in, which is, can we show an example of block coding? So since the scope of this camp was Android Studio, unfortunately, we won't be able to move over to that, but we will be happy to point to resources, which will make it really, easy to pick it up if you want to go that route. But if you know Java and want to work with Android Studio, then definitely, this will be helpful.
and so Colton and Carter, just let me know when you guys are at this step where you have your control hub powered on and you have the USB-C cable connected.
So what we can do is, at this point, let's talk about the first program, have them uploaded, because you want the build to include that first program. So that can be tested. Maybe you can use that other device.
There's the glare of the light. I think that's the problem.
Oh, okay, all right. So you guys had a question. No, the USB-C part gets plugged into the control hub. But oh yeah, you guys are on iMac. I forgot. So does your guys' iMac, does it have a USB port in your computer, or do you? Well, okay, all right, yeah, all right, it probably should. So basically, the USB-C end goes into the control hub, and the USB part,
USB-A.
part goes,
USB-A and
that goes into your computer.
And then if you have a Mac that only has USB-C ports, you would use an adapter. Like
Yeah, like for example, the computer we're using right now is a Mac, so we only have USB-C ports on it, so we need to use an adapter. So yeah, Colton and Carter, just let us know when you have it plugged into your computer and the control code.
Does anybody else have it? Already? Oh, we don't have it.
So Vihan and anyone else who doesn't have the hardware and is watching. So what the way you can benefit is once we start writing and downloading the code, you can follow along. It's just that you won't be able to download it to any electronics, but you will be able to see a demonstration here as that code is run.
Okay, all right, yeah, so it's plugged into your computer, just like plug it into the control hub. And there should be like, on your control hub, there should be like only one spot, like where you can plug in a USB-C cable, so you shouldn't get it wrong, so it's that part. Yeah. I don't think they need that out.
Also, the cord is too short for each.
Oh, alright, that's, well, you guys will probably need just like you guys have a longer cable then?
So if you have an Android phone, you can use that cable from the Android phone charger because those would be USB-A on one end and USB-C on the other end, or any other USB-C cable that you have would work. But it should be a cable that also works for data. It should not be just from a charger.
Yeah, USB-C.
Although the phone one would work, but anything else, like from a GoPro or something, would still work.
The one from the phone.
Okay, let's get started on getting the first code loaded up.
Alright, so we'll. Wait, do you need right?
Write the first one for knowing the motor, whichever is the first one.
Okay.
you guys decided.
Alright, so I think, we spent enough time on that. So I think now we're gonna move on to actually writing our first program.
And in the meantime, Carter and Colton, you both can be running that and getting that set up, because it'll take some time here for this code to be written and shown. And then once that's available, you'll be able to include that in your build.
Alright, so yeah, you guys are gonna want to go to your Android studios or studio, not studios. Alright, yeah, so just open that. Yeah, make it pull. Oh, okay. Wait, okay, yeah, and stop sharing.
We'll just pause sharing for a second.
Alright, guys, no taking videos. Okay.
Take a picture.
You in Discord.
Or close that window so that you can open it.
Which one?
Close the one. which-
Tab.
Yeah, okay, so
And you go to that window.
no.
No.
There you go. Alright. Okay, so first program.
Do you want to start sharing?
Yeah. All right. So, all right. I finished that. I finished that. So now, I'm gonna share. All right. So now, basically, you guys should all be on Android Studio. And then, yeah. All right. So what you want to do is, yeah, I'll show you. Yeah. All right. So basically, first of all, you guys probably wondering, where do you actually like write your code? So for that, you want to go to your team code folder. So just click the drop down, and then in Java, like click the drop down, and then you can see how I already have a few programs here. So this is basically where you guys want to write all of your custom
Highlight the team folder. That's what we want. No. Highlight the-
like this.
Not the files. Okay.
This, oh yeah, oh this, okay. Yeah, okay, yeah. So in this, yeah, this is where you write your custom code. So to make a new file or a new program, you want to right click just anywhere underneath it and go to new and click on Java class. And you can name this, for this, you probably just name it first program. And then you can click enter, create it. Oh yeah, so if you guys have your GitHub like repo set up, you should get this pop up. So pretty much like most of the time you want to click add. So, yeah, so do that. All right, and then send a message in the chat if you guys are at this point. Are you guys all at this point? Yeah, so Vihan, Colton, and Carter. Yeah, just send a message in the chat when you guys are at this point, or if you need help to get to this point. Okay, you guys need help. All right, so all right, in that case, I'm gonna request you guys to share your screen. Colton and Carter. Okay, all right, yeah, Vihan, that's good. You're done. All right, so yeah, so Colton and Carter, just share your screen and I'll take a look at it. Okay, so basically, all right, so click on team code. So like you can full screen your Android studios. That might make it easier. Studio. Yeah. All right. So click the little like arrow that's pointing right. So like don't click like the folder, just click that little arrow. Yeah. And then click the same thing for Java. Yeah. And then now just right click. Do you see like where the readme thing is? Just like right click.
Right click above that on the package.
Yeah. Click. No, it's click new.
On the package. So I make sure, because I'm actually on my board, something else will not. So right click on the package is the way.
Right. Yeah. Wait, do I have to do that? Okay, all right. Just click somewhere else on your screen. Just just kind of get rid of that. So just like click somewhere else on your screen. Yeah, okay. So now go to like that org.firstinspires.ftc. So, yeah, all right, you can expand it and then just right click on that instead. Yeah, and then now do the new Java class. Yeah, and then you can name it like first program. Oh, I think. Oh wait, just redo that again. Yeah. Yeah, and then now just name it first program. Oh yeah.
So
No
you want
spaces, yeah.
you want to start with an all cap, like a first letter has to be capitals,
Yes.
and
yeah.
you should not have spaces in the name.
Yeah.
Well, I mean, just first letter being capital is enough, but that would work. Program or something like that.
First and then just program. And then just click enter. Yeah, there you go. All right, that's good. Good job.
So if everyone's at this point, you can, so Ron, you can start sharing your own screen.
Yeah. So yeah, now I'll start sharing my screen again. Yep. Okay. All right. So now the first step. Oh, actually, all right. Wait, let me reshare. So that let me reshare real quick. All right. So now we'll go back to the slideshow. So all right, we covered this. So all right. Yes. Okay. So this is like kind of like how to set up like an actual like FTC program. So basically, all right. First of all, the FTC SDK there it offers like two op mode classes, which is basically like two ways of writing programs. So the first one is linear op mode, and second one is just op mode. So in this camp, we'll be using linear op mode. So yeah, so basically what you want to do is yeah, let me go back to the Android Studio screen. So what you want to do is right here, just write extends and then linear op mode. Yeah, extends, and then you'll get an error, but like that's good. You should have that error. And then after you do this, just right click on the error, click show context actions, implement methods, run op mode, and then click OK. And then now this is like you have it set up good. So yeah, so just send a message in the chat when you're at this point. Oh, okay. So Colton and Carter, you guys said your driver hub didn't charge, so you won't be able to code the robot. That's fine. You guys will still like have a lot of programs that you can like after this camp, you guys can charge your driver hub and then you can test all these programs. So that should be fine. You guys can still follow along pretty well. So yeah. Just when you're at the step that I'm at, just send me a message in the chat.
So Ron, can you show how you made the method show?
Oh yeah, I'll do that again. Yeah. So all right, let me just delete this. So yeah, so basically I wrote extends linear off mode and I have an error. So basically what you want to do is so you want to right click on your error and then you want to click show context actions. And then now you want to click implement methods and then just click OK. Yeah, just like that, and it should pop up. So Vihan, Colton, and Carter, just send me a message when you're at this point.
So request.
Good job, you've done.
Yeah, sorry. Good job, we have. So requesting everyone to please make sure that you have all these lines that you see here. So the first one package that you would have automatically gotten it, and then import linear op mode. So you should be able to see that. So Ron, can you run that again? Because it's not very obvious how those showed up all of a sudden. So I would suggest go back to where you were without the import, without the method, and not even have the extent.
Yeah. Okay. All right. Excuse me. So basically, all right. So yeah, this is all right. This is where we were earlier. So I'll just show the whole process again. So basically, you just want to go here, and you want to click. You want to write extends linear off mode. That's like the first step. And when you do that, like the import should automatically pop up, so you don't have to worry about that. And then you should have an error, which is good. So yeah, Colton and Carter, just send me a message when you're at this point. Also, a reminder that you guys don't have to like always use the chat to send me messages. You can just unmute. That's like quicker too. So we'll like move through faster.
You can also, this is an easier way to just cover.
We have the error thing, but we don't have the import thing.
Oh, you don't have that in, oh, okay, all right. In that case, I'll just send this in the chat and like you guys can just quickly copy paste that.
Send it to everyone.
Yeah. Yeah, so yeah, just copy that and then just like put it like underneath the package.
They can just hover over that and then click implement methods. It's way faster.
So you can.
Yeah, watch. Alright,
Oh, okay, all right. Oh yeah, so we actually have like a better way of like, all right, so yeah, Colton and Carter, once you guys like put the get the import there, just like let me know and I'll show you the next step.
No.
Yeah, so Colton and Carter, do you guys get the import yet?
Yeah, we got it in, but there's no like orange, like the import is not orange on ours.
Okay.
Can you share screen?
Yeah. We'll just have you share your screen.
Okay.
Okay, all right, so. Oh, okay, all right. I know why. You guys just have to, your linear off mode, the L is lowercase, just capitalize it and then it should work. Yeah, and then also have a space between that like bracket and linear off mode. Yeah,
So
Alright.
please remember, Java is a case sensitive language. So it's very important that you have all the uppercase, lowercase exactly as required. So now they should be able to right
yes,
click and
yeah. So now, actually, Rishi showed me a better way. So just hover over that like error, like just put your cursor on it. Yeah. Oh, what the?
Oh
yeah.
Oh yeah, okay, yeah. And then now, just click. Do you see implement methods like kind of right underneath your cursor? Just click that. Yeah, all right, and then click OK. Yeah, there you go. All right.
And as you learn Java more, some of this will start becoming very obvious. So please don't feel overwhelmed by the number of things that are having to be done.
Okay, so now we're all ready for the next step. So basically, all right, yeah, let me go back to the presentation. So there's two stages of a program. The first stage is the initialization stage. And this is where you run like all the things necessary to like set up your robot before you actually press play on the driver hub. So yeah, so that's another thing. When you run a program on the driver hub, there's like a button that's gonna say init. So you click init, and then you like after a little bit, like once it finishes initializing, then you can actually click like the play button. So basically what happens in the initialization is like that's where you configure your motors or your webcams and all that. And then when you actually click play or start, that's where your robot's actually gonna start like doing stuff like moving like motors, servos, and whatnot. Okay, oh yeah. All right, we have like a demonstration. So if you just look at the camera, like our video, you'll be able to see it on the driver phone. It's kind of tough to see, but yeah, that button says init. Oh wait, yeah, let me mirror the camera or unmirror.
Just one again, so I can see.
You have to
Like-
stop sharing.
Yeah, I have to stop sharing this.
You can pause share. Yeah, please pause share.
A pause share is just like stop share. Yeah, so yeah, you guys can see the button says init. Yeah, then once you press it and you wait a few seconds, it should be initialized.
So
Press
so
it.
this is very important to understand, because when you press init, there's certain code that is going to get run. And till you hit play, nothing else would have run. And then when you hit play, the rest of the code is going to run. So the way you're going to think through your program and structure it will have to depend on what you need done before you actually start the game or start the play. Because let's say you have 2 minutes for the driver portion. When you click in it, it will run some code and be ready, but it would not have yet started running the program, which will get run after you hit play. For that, you have to hit play. So any initialization or getting things ready, getting the sensor ready, getting the webcam ready, all these things should happen after you click on init and before you hit play, so that you don't lose time with all those initializations after you hit play.
And then when you hit play, it'll start running with that. This code does some object detection stuff that we won't be.
Well, we will show a
We'll show
different
it.
one here.
Yeah, but we're not.
So- So Ron, can you switch over quickly to showing another?
Yeah.
Get that code. So we do want to take a break here in about 5 minutes. So let's see if we can get the motor code on there.
Yeah. Oh yeah, so basically writing your first program. So yeah, so we did these 2 steps already. Yeah, so now the next step would be to add, yeah, right here, you want to add @teleop. And this basically on the driver hub, when you're selecting a program, yeah, we'll show it again. So I'll just stop sharing again real quick. So yeah, so basically,
So you'll see these 2 arrows at the top here.
yeah, the two, yeah,
So
2
this
arrows.
is for
That-
selecting autonomous programs.
Yeah.
Autonomous, and then this one is for selecting Teleo. So
Yeah.
that's what the.
Yes, yeah, so the annotation, like the @teleop, what that basically means is like when you download your code to the control hub, on your driver hub, it'll like because we did @teleop, the program will show up under the teleop section. And that's pretty important. That's you want to get that right. Yeah. So all right, so I'll move on to the next step now. So all right, so yeah, next step is you want to create a motor object. So this is where kind of like what we talked about earlier, classes and objects. This is where that kind of comes in. So you want to do DC motor, and then you can name this motor variable like test motor. And then oh yeah, and then you always want to remember in Java, you always put a semicolon at the end of every line, unless it's something like this where it's like the brackets. But anything else you want to put a semicolon. Yeah, so now after you create your motor object, in run off mode. So remember I said like there's an initialization part and then like the actual like start stage. So to separate that in your program, you need to use wait for start. So basically everything above wait for start is going to be your initialization, and everything after is going to be like your actual program running. So in the initialization, well, this is where you want to configure your motor. So to do that, you want to do test motor equals hardware map dot DC motor dot get. Oh, wait, let me just make sure this is right. Yeah, so DC motor dot get, and then in here in the parentheses, just like I'll have quotations, and then you just like say the name of your motor. So I'll just call it test motor with a capital T, and you put your semicolon at the end.
So this is probably a good moment to start to explain what the hardware map is and how you work with that, with the configuration.
Yeah, so you saw I did something so this is what I did like in the code to configure the robot, but that's only half of it. The other half is on the driver hub. So let me stop sharing really quick, and that way you guys can see the video better. Yeah, so basically it's on the driver hub. You need to click the 3 dots here, and then it's a bit tough to see, but you see this third one says configure robot. You want to click on that,
And then once you click on that, like up here, this says new. So this is basically where you can have multiple configurations for your robot, but we're gonna make a new configuration just to show you guys. So you want to click on new. Yeah, there it is. So I clicked on new, and then this says control hub portal. So you want to click on that. And if you have an expansion hub connected to, you'll see like expansion hub portal too, not just the control hub portal. And now we click on control hub. Yeah. Yeah, so now I click on control hub. So it's a bit tough to see, but this one at the top says motors. You're gonna want to click on motors. And then now this is where like you actually wire. This is like yeah, this is where we do the other half of configuring your motors. So you see 0, 1, 2, and 3. So that corresponds to the ports on your control hub. So for example, let's say you plugged in a motor to like port 2 on your control hub, then you would go to port the purple and blue linking just mean here in the configuration. And these are all these wires are basically those are the motor ports. So yeah, so it's a bit easier to see like on.
So this is an expansion hub, but
yeah.
the ports are being located in the
Yeah.
same, exact same spots.
Yeah, so these. I don't have video here now.
It's so weird.
Alright, so actually, you guys see, these are the 4 motor ports. So this is 0, 1, 2, and 3. So let's say we plug the motor into port 2, then back on our driver hub, where it says 2, you click on that. And then here, all of these are just like different kind of motors. So you find your motor. And so we're using Toyota motors, so we would click on that.
And this may be hard to see, but these are pretty standard instructions which you're going to be available when you go through some of the documents that we have provided links for at the end of the slides. So definitely we would suggest looking through the document because it'll be much easier to see these values and get a description of all the possibilities. Yeah, please proceed.
Alright, so I clicked on the motor type, and then the next step is you want to click on like this, where you can actually type stuff. And so if you remember earlier in our code, we set up that motor as like test motor. So like capital T, EST, and then capital M, OTOR. So you want to type that exact thing here. Yes. Yeah. Okay, so you can see I typed, it's tough to read, but I typed in test motor there. Yeah. All right. So now you can click done, and then save. And yeah, you can just here you just enter a name for the configuration. Okay, that's all right, Vihan. We'll go back to the code and like show you again. Yeah. So here you can enter a name for your configuration. So we'll just call this like coding camp. Okay. All right, so now we finished the configuration on our driver hub. So that's pretty good. That's a pretty important step. And that's something that like a lot of new teams will struggle with.
Yeah. Alright, so I'll share my screen again and we'll go back to the code. So yeah, so Vihan, which part exactly do you think you messed up on? And I mean, you can probably just looking at this, you can just change it.
So it's 2:45 Pacific time. Let's take a 10-minute break. So we'll get back at 2:55 and resume from that point. And anyone who wants to make sure their code synced up with what we have here. Please look at what is shared and make sure that your code is also brought up to exactly the same lines. And then we'll pick up from there in 10 minutes.
All right, everybody, we will be resuming the camp. So, all right,
So have you paused the recording? No, that's okay. All right, you can continue.
oh yeah, we were muted. So. Okay, all right, so yeah, we'll be starting again. Just like raise your hand or talk or send a message in the chat that you're like back at your computer and you're not like still doing something else. All right, good job. You guys are all back. All right,
I think. So Gemini and,
that's like the
no, let's just make sure they're here too.
oh yeah.
So, Lowell, or I think that's Amelia and Gemini, could you please confirm if you're
That's like
back?
the other computer. That's like the iMac.
Oh, right, that's the
Yes,
iMac.
you're asking me something?
Yeah, I was just making sure you were back because we just completed a 15-minute break.
Yes, I'm over here. Yeah.
Okay, all right.
Okay. All right, good. All right, so okay. All right, so we will. Oh yeah, good job, Vihan. You said you did it. That's good. So now the next step. So we finished initializing the motor. So now the next step is to actually like run the motor, like make it move. So it's actually pretty easy. You just want to do test motor dot set power, and then so the way power works for these motors is it's like a value between -1 and +1. So anything below 0, negative, it spins it like it spins it backwards, and if it's above 1 or above 0, like positive, it'll spin it forwards. So we want to spin the motor at 50% speed maybe, so we can do
So
0.5. So yeah, that would be 50% speed. And then now we don't want it to just like keep infinitely spinning. We want it to maybe stop spinning after 2 seconds. So to do that, you want to do sleep. And then you choose like the amount of milliseconds that you want it to spin for. So we want 2 seconds, so that's 2000 milliseconds. And then after that time has elapsed, you want to stop the motor. So to do that, you test motor dot set power, and then you do 0% power. So yeah, basically, so what this program will do is spin the motor at 50% speed for 2 seconds and then turn it off. So yeah, so just like do like give like a thumbs up or something like that when you're at this step.
Oh, true, okay. We can do it.
Yeah. Yeah, just a reminder, give like a thumbs up or chat, or like actually not thumbs up, raise your hand, because the thumbs up like goes away after a few seconds, so I might miss it. So yeah, so either raise your hand or send a message in the chat when you're at this point.
Yeah.
We can focus on university of Eastern Martians.
Oh yeah, that's pretty good. Yeah.
On university, I think it's command plus.
Okay, all right, good job, Vihan. You're at this point. Yo, what the heck?
check.
Check the chat.
So Colton and Carter, if you have been able to write this much code, please let us know and then we can proceed.
So we have that much code, but there's like, it says that there's errors in it.
Okay, all right. In that case, we'll have you share your screen.
Okay.
Okay. Oh, okay, I see. All right. So what you want to do, all right, so the reason there's this issue. Oh, okay, all right. So one thing, when you in your sleep statement, you don't have to say milliseconds, it's just automatically milliseconds. You can just like delete that part. And you can delete the colon too.
Yeah, that is the
Yeah.
automatic one and that is okay.
Yeah. And oh, also one more thing. So I see you have a colon at the end of every line. You have, I think you have to change that to a semicolon.
And then line number 13, I think is missing a semicolon.
Yeah,
Same as
yeah,
line
yeah,
number
like
15,
yeah, 15 and 13, yeah.
at the end of the line. Yeah. So all in Java, all statements end with a semicolon unless you're starting a method or starting a class.
All right, so now to your final issue is that you don't have the import for the motor. So on my computer, it like automatically adds the import. So, but on your computer, I think what you'll have to do is just right click the red, like so like right click test motor. Yeah, and then click show context actions. Yeah, and then oh what? Okay, that's kind of weird.
No,
Doesn't
because
say
it
that.
is very specific. It's better you
Okay, all right.
understand the import.
Yeah, all right. In that case, I'll send you guys like the import you need. So just a second.
If DC motor was used, and it was in red, then you would have been able to use that. See, it's missing.
Oh,
the
wait a
DC
sec.
motor.
Oh, okay. All right, yeah. All right, actually, all right, here. I think I know what the issue is. So basically, next to like, all right, you know the line with linear off mode? Yeah, line 5. So go like to the end of that line and click enter. So yes, yeah, go there, click enter. And now type DC motor with like a capital D. And then see, yeah, then you can press enter. It'll autofill. Oh, okay. All right. Yeah, backspace. All right.
Motor,
Type.
yeah.
Yeah, just yeah. All right, now. Okay, yeah. Now, press space. And now type your test motor, like with a lowercase t. Yeah. And semicolon. Okay, all right, yeah. That's good. All right, now just right click DC motor. Yeah, and show context actions. And yeah, click import class at the very top. Yeah, there you go. Okay. All right, that's good. Okay, so now this program will download the code and you guys will get to see it in action. So yeah, okay, so now let me download. Oh yeah, so I'll show you guys what it looks like to actually download code. So basically, this is my Android Studio screen. No what?
It exits the program.
Yeah. So all right, so if you take a look right here, it says Rev Robotics Control Hub. And right now I have like the control hub. I have that wire plugged in from my computer to the control hub. So that means that that's good. This means that the control hub is connected. So all you have to do is just press
The shared screen
run.
is not showing it. Can you make it smaller? We want to make sure.
Oh, yeah. Okay, wait. All right, just a second.
Is it the monitor?
Oh, it's just a monitor. They'll be able to see it. Yeah. Okay. All right. Just a second, guys. We have some technical issues. Okay. All right. Yeah. Yeah, there you go. That fixed it. So yeah, you guys can see I pressed the run button. So now if I open up this build tab down here,
Can you
it
stress
is
on the fact that
downloading.
it should show Rev Robotics Control Hub?
Yeah,
and-
yeah.
and
So yeah,
that will
there's
happen only if you connect the control hub.
yeah. So basically this here, RevRobotics Control Hub, this will only show up if you like connect that wire from your computer into the control hub. So that's like, I have that connected right now. That's the only reason this is showing up. And like when this is showing up, it means you're good to go and ready to download code. So yeah, so basically right here, it's like, this is my first build like in this project. So it will take a while. Yeah, 54 seconds. So that did take a while, but
Can you show us? It's showing half. Can you
yeah,
show-
it shows it in there. Just an issue.
Okay.
All right, so yes, so now it's like doing the actual run bit. So it's almost downloaded. Yeah, and then you see the launch succeeded. This means that I successfully downloaded the code. So now we're ready to test out the program. So first of all, I think you guys might be able to see that the control hub is blinking blue. But let me actually stop. Alright, so if you guys can see here, oh yeah, if you guys can see here, the control hub is green, there's a green light. So earlier when I was downloading the code, it was blinking blue. Which that now shows that's downloading code, but right now it's from green, so that means that the code is downloaded. So I'll take the driver hub, and then now, you can see, if you remember, we put the @teleoff in our program, so I'm actually using the teleoff section. And I don't know if you guys will be able to see this, but it's the first program. So I have first program selected. So now I'm gonna initialize. And then, yeah, okay, so I wait these and it should be initialized now. Alright, so yes, now it's initialized. So now when I press play, it should turn this motor on for 2 seconds and then stop it. Yeah, you're good. Yeah, there you go, perfect. So it did exactly what we expected it to. Yeah, that's good. Alright, so we just like coded, so that program, we just coded a motor, so that's pretty cool. Alright, so now I'll share my screen and we'll get going on the second program, which is coding a servo. So basically it's pretty similar. It's just a slightly different. So let me find my program here. Just a second. Yeah. Okay, so I have the servo code here. So I'm gonna just copy, I'm gonna copy paste this code into the chat for you guys. So that'll probably speed up the process a little bit. So just use that. All right. Oh, wait. Okay, chat. Do I make them make a new program or just?
Yeah,
just
give it a different name.
Oh, okay, all right, so you guys are gonna need to make a new program now, so that was a motor program, so now just make a new program, so
Turn servo.
yeah, okay, all right, so this one, so if you remember, you just have to right click and then new, and then click on Java class, and we'll call this like turn servo. Oh yeah, so turn servo, then just press enter. And then, yeah, remember to add the file to Git. Oh, okay, all right. So Vihan had to go. That's all right.
So Vihan, you should be able to catch up on the
No,
rest
he
of the.
he like left already. Okay. Yeah. Okay, all right. So Vihan has left. That's all right. So basically, yeah. So if you remember, we have turn servo, and then to speed up the process, what we'll do is just go back to your like first program thing and just copy paste the whole thing. Yeah, just copy the whole thing, and then paste it into your turn servo. And then just change like first program to turn servo. Yeah. So yeah, so call Colton and Carter, just let me know when you guys are at this point.
Do I delete the stuff that's already in turn servo?
Yes, you do. Yeah. So just like basically select the whole turn servo thing and just like replace it with your first program.
Okay.
Yeah, actually, you know what? If what we can do is like, because it's just like, you guys now, you guys can share your screen. And I think that'll make it like a bit like we can go a bit quicker that way because I can see what you guys are doing like the whole time.
Okay.
So, all right. So, yeah. All right. So, what you guys want to do? Yeah. Go. Do you have your like first program? Do you have all that code like copied in your clipboard?
Yeah, I do.
Okay. All right. So now just press Command A. Or oh yeah, that works too. And then now just like do Command V. I just paste it. Yeah. All right. And then just change first program to turn servo like in your pro like yeah, like do you see how it says like first program, like public class first program? Change that to turn servo. Yeah, perfect. All right, good job. You guys already have the servo object created. Yeah, just add a semicolon at the end of it. Like at the end of turn servo. There, I'm sorry, my bad. Test servo, like when it says servo test servo, just put a semicolon at the end. Yeah, there you go. All right, and then now we need to initialize this, like, or configure it the same way we configured the test motor. So, go to like the end of the test, like hardware map line, like, up and go to end of line 14. Line 14. Yeah, go to the end of it and then just press enter. Yeah, and then now do test servo equals. Yeah, test servo equals hardware map dot servo. Yeah, you can just press enter. Yeah, dot servo. Yeah, press enter. All right, and then dot get. Yeah, just do dot get now. Yeah. Sorry, GET get. Yeah, and then you can press enter. Yeah, all right, and then now do code.
No, you
Oh.
don't need the brackets.
Yeah, you do. You need those brackets. Okay, so backspace. Yeah, and then like they'll have the brackets.
Open and close bracket.
Yeah, open and close brackets. The like
The rounded.
rounded ones, like it's like basically the same
Parentheses.
as the one above, pretty much. Like,
Yeah.
All right, and then inside of no, it's the same as like the test motor one with like the round parentheses. Yeah, and then inside have quotations and just write like test servo. Yeah, all right, good job. And then put a semicolon at the end. All right, so now Vihan is back, so I'll share my screen again. So yeah,
Going through the slides.
Yeah. Okay, so yeah, all right, so basically, Just a second, guys. Okay, all right. So yeah, so all right, so we're at this point, and so now I'm gonna introduce telemetry.
I think
So
for test server, line number 18, they had lowercase t after get. Make sure.
oh, it doesn't matter. It's just like matters for the oh.
Make it match this one.
Okay,
That's what-
all right, oh yeah, so Colton and Carter, yeah, in like when you guys set up like the hardware map, you guys had like a lowercase t, just change it to an uppercase t. It's like, it'll make sure like the hardware configuration, like when you configure it on the driver hub, it's better to have like an uppercase t. All right,
All right, I fixed it.
okay, all right, good. All right, so, oh yeah, now I'll go through a slide that talks about telemetry. So, okay. All right,
Wait, first, just quickly talk about this. The examples,
Hmm?
sample code.
oh yeah. Okay, yeah, so something I've missed talking about earlier is sample code. So basically, I'll show you guys how to get to sample code. It's in under FTC robot controller, you go to Java, and then it's the external samples. So basically, these are a really useful tool because they have like wait, let me go back to the slide. Yeah, it's a really powerful resource because it provides like examples of various coding applications, such as like moving a motor, vision processing, and like also like has some examples of like coding a drive base. So this is like a really important thing
Yeah,
to look
so
at.
this is really one of the best resources you can find easily for writing new code, because whatever we are putting together, you will find that pretty much all of that is available in these sample codes also. We are putting it together step by step so that it's easier for you to understand. But once you have reached that level of understanding, by looking at these sample pieces of code, you'll be able to quickly understand how to work with various kinds of hardware. So how to work with the gyro sensor, how to work with the touch sensor, the distance sensor, and then how do you work with multiple wheels which you're configuring as a drive base. So all of that. We will cover as much of that as possible today. We have about 40 minutes left. We'll cover as much as we can. But please know that this is one of your biggest or greatest resources for finding out how to work with various pieces of hardware. And also at the end of our slides, we have 2 pages of links. And those are kind of the best resources you will have access to. So at any point you have questions, please make sure you are going through those resources, especially in the next 3 weeks. Go through as many of those resources as you can, because that will set you up for a good season that way. Okay, can proceed.
Yep. All right, so now, yeah, moving on to the telemetry. So, yeah, right here. Yes, all right, telemetry. So, all right, not really in previous slides, but if you see here, you can see I have this like telemetry.add data thing. So you guys are probably wondering what that is. So that's what this slide will talk about. So telemetry provides, it's like a logging system. So you can constantly see like the values of variables throughout like a program. So like if you're running like a teleop mode and you want to like see like what power your motor is running at, then you can log that in your telemetry and you can see like what power it's at like throughout the program. So this can help with a lot of stuff like debugging. So if you're having a certain issue and you're not really sure like what it is, you can use like log the values of certain things like motor power or like or sensor values, yeah, and encoder values, and that can help you debug the issue. And it can also help sometimes with tuning. So if you're like trying to have like some kind of control algorithm, which is a pretty popular thing to do, this can help you like tune that. and it can also help with a few other things. Yeah. So telemetry basically shows the way it works is you have like telemetry, you should do it in the code, and then it'll actually show up on your driver hub screen. So if you see this image here, it's like this is telemetry right here. So it's kind of actually what we did here. So we had like this robot status, and then it says initialized. So what that would look like here is this status would be replaced. Oh, shoot. All right, this status would be replaced with robot status, and then this would say like initialized. So yeah, so that's how telemetry shows up. And in the program, the way it works is you use telemetry.addData to like add data to it. And then at the end of like every telemetry.addData, you need a telemetry.update. So that way it'll actually show up on the driver hub screen. So yeah, so that's telemetry. So I'll go back to the code now. So
Also, if you're running in a loop and the value of something that you're monitoring is going on, it's changing constantly, then you want to run that telemetry.update at the end of the loop, so that throughout the running of the loop, it'll keep updating for every new run of the loop.
okay, so yeah, sorry. So you guys can add these two lines to your code. Oh yeah, and Vihan, you like kind of joined back like a little bit after we started on the servo code. So basically all you missed really was like we just create a servo object, and then we put it in the hardware map. So just like add these two lines of code. So yeah, so just like everybody make sure your code just looks like this. Yeah, and I can try and zoom in a little bit to make that easier to see. Yeah. And give a thumbs up or put it in the chat when you're done.
And just to quickly talk about the difference between a DC motor and a servo. So DC motors are firstly more powerful, but also that means they are heavier. And DC motors, they can rotate continuously up to, there's something called an encoder that is already inbuilt into the DC motor. And what the encoder does is it helps you keep track of how much the DC motor has rotated. So that's how you would work with DC motors. And then for servos, there's two modes in which you can use a servo. One mode is called a continuous rotation mode, in which case it works almost entirely like a DC motor, except there's no encoder values for you to keep track of. But when you use it in a servo mode, which is not continuous rotation, what happens is it will behave like it can go to exact degrees of positions as you want it to go to. Now, this one here in our example, it's capable of rotating 5 times in the servo mode, but there are many servos which cannot go a whole turn. So let's say there's a 300-degree capable servo. What that means is there's, like a whole circle is 360 degrees, but that servo is only capable of turning 300 degrees. So the 60 degrees which it cannot turn, that's kind of like a dead band. And please make sure that when you're using those kind of servos and when you're mounting hardware on that, or when you're mounting some part of your robot on it, make sure that those 60 degrees which it cannot use is not in a range that you need the robot to be working in. This may be hard to understand, but once we have that servo moving, although this servo is capable of moving the whole, like beyond 360 degrees, so it's hard to explain with this one. But just be aware that there's something called a deadband with servos, and you don't want the deadband to overlap with the region where you want your robot's parts to be moving. So when you mount the servo, you need to be aware of that and rotate a little bit before you mount the hardware to take care of that. Now, what's the advantage of a servo? It can go to a certain, if you ask it to go to exactly 75 degrees, it will turn to 75 degrees and it will stay there. It can actually hold power there for quite some force. Whereas with the DC motor, again, with DC motors, there is a hold option, but servos are better useful or more useful when you want to have it rotate to specific positions. And another big advantage of servos is they're much lighter. So as in a few minutes here, we'll show one of the robots from the power play season, and you'll see how the servos were used where the arm had to extend the most, because when you go with heavier motors, they will cause tipping over or just be a much larger weight than you want to handle. Whereas with servos, you'll have the ability to rotate or whatever functionality you want without having too much weight. Okay, with that you can move on.
All right, so, oh yeah, Colton and Carter. So you guys' program looks like this. All right, that's good. Vihan, are you also at this point? Oh yeah, I think you sent something in the chat. Oh, okay. All right, you're
Yeah, I'm a little bit behind.
okay, all right. That might be do you have the import? Do you have this servo import?
Let me check. Yeah, I do have it.
Oh, you do have it? Okay, all right. In that case, I'm gonna ask you to share your screen. So that way I can like see what's going on. Oh, okay, all right. The reason is you have servo dot test servo. Just delete that dot and just like have a space instead.
So here.
Like, no, it's line number 12. Yeah, there. Yeah, so just click on that and then delete the dot. Yeah, and then push and then space. Yeah, and then yeah.
Oh, yeah. Okay,
All right,
thanks.
and then for your telemetry, it's
Yeah.
robot status, and then oh yeah, wait, I'll go back to my shared
Line
screen. and
number
you can see-
19, you needed a semicolon.
Oh yeah. All right, yeah, all right. So what I was saying is like for the telemetry, it's like so yeah, you want robot status, and then you have to have a comma afterwards, and then a space, and you have like another set of quotations, and that's where you like put like initialized. And then so if you want, oh yeah, okay, all right, I forgot if you do it. So if you want to like see like the power, like all right, let's say, all right, yeah, our servo's turning. So if you want to see the servo position, for example, you could do like a telemetry dot add data, and then in here you would do servo position or servo pose. Yeah, and then comma, and then another set of quotations. Then in here you would do test. Oh wait, yeah, sorry, no quotations here. You would do test servo dot get position. And then now what this would do would basically show you the servo's position. Like after, so all right, we know the servo's position is going to be 1 because we put this after the servo dot set position. So yeah, so then all right, and then we have to add the telemetry dot update too.
Okay.
Okay, yeah. All right, yeah, and then at the end we can see. All right, so yeah, we can. Yeah, all right, then we can see our position at the end. So just by doing that. Yeah. We have to set it. So now I'll show you guys really quickly how to configure the servo like on the driver hub. So if you want to look at the video really quick, I'll just stop sharing my screen so that you guys can see it better. Yeah, so basically if you look at the video, yeah, you just click control before the control hub. And now instead of clicking on motors, you want to click on the second thing with the servos. And then here we have our servo plugged into port 5. So I would scroll down to port 5 and click that. And servos, there's like it's a lot easier to set it up. You just like scroll all the way down and click servo. Yeah, so basically if you see on board 5, I have servo selected there. And now I'm gonna type the name. The name is just S.
With a capital.
Servo, yeah, with a capital T and capital S. Yeah, so now I have the test servo type there. And now you just click done, and save. Yeah, all right, and then now this servo is good to go, so I'll continue. All right, so now I'll share my screen again and you guys can finish up on the code. Yeah, so yeah, in the meanwhile, I'll just download the code. All right, so yeah, so just like send a message in the chat or like thumbs up when you finish writing this code. No, I'm just doing because we're sharing the PowerPoint, right?
So
All right, so now we're gonna go ahead and test the code. So, I'll stop sharing. So basically, gonna first we're gonna select the program on the driver mode. Turn servo. Yeah, turn servo. So I'm gonna initialize. And then now if you guys see, there's like that robot status initialized telemetry right here. So I know that it's properly initialized. And then now if I press play, the servo is gonna turn. And I want you guys to like look at how that affects the telemetry. So I think like at first the telemetry is gonna say the servo position is like 1, and then afterwards it's gonna say servo position is 0. So yeah, servo position. Yeah, it says 1, and then
you can run that again.
it's like, yeah. It's kind of funny, so. Oh, wait, first we'll just show you guys what.
Yeah, just show that running.
Yeah. So if you guys look at this right here. It's about done. This is.
So it went from position 1 to position 0. So that's great.
Yeah, wait. Yes, yeah. Isn't it supposed to spin back though?
If you're done 0 and 1, it will fall back. You want to show the telemetry now?
The telemetry, yeah, sure. Yeah, so you guys can now look at the telemetry. Yeah, now you guys can just look at the telemetry. So it says yes or mission.
It's stay there.
Okay, I see. Oh, yeah, it's like, okay, that makes sense. It's already at.
Okay, so next, what you can show the slides next for the next few programs, and then let's talk about machine learning a little bit.
Oh, okay. All right, so now,
Show the other programs.
oh yeah, let me share my,
Share.
yeah. So let me share my screen again. And so now, that's like probably, we're gonna take a little break from the coding. Because I showed you guys kind of how to do a lot of this stuff. So now we're gonna like
Let's
just
go through
look,
all the other, yeah.
yeah, we're gonna look through kind of like some other ways to code. That we wouldn't have time to get to if we like tried to actually code it up. So yeah, so first off, this is coding a motor with encoders. So basically encoders is something you can use, there's something you can use to like track how much a motor has turned. So this is really helpful in autonomous and also in teleop if you want to like set it up so that like you can press a button and it'll like, let's say you have a motor connected to a slider. So you can press the button and it'll move that motor a certain amount. So like the slider will get to a certain position. So that's what this encoders are really helpful with. So to do that, it's you basically there's no extra setup required. It's just like a different method in the for the test motor that you have to use. So you need to have a while loop, and then here this is a method like this public void move motor to pose. That's a method. So basically this int encoder pose, it's like you can pass a variable in it, or you can pass a number in it, and then wherever encoder pose is used in the method, like that number will replace it. So for example, if you see here in the actual program, I have move motor to pose and I put 1000 in it. That means that in this method, encoder pose here is going to be like replaced with 1000. So, all right, basically what this does is while the test motor.get current position. So this is what the encoder is really. It's like the get current position. It like returns the encoder's value. So when it's less than the encoder pose, which is 1000, then the test motor will go at 50% speed. And then when it breaks out of the loop, so when it basically gets like more than 1000, it'll stop the motor. Yeah. So the next slide, this is programming a gamepad. So a gamepad is if you see on the camera really quick, yeah, that's a gamepad. So that's what you use in teleop to control the robot. So basically you have to make a gamepad object here, like gamepad, test gamepad. And then you have to have a while loop. And this while off mode is active means this while loop is going to keep running until you stop the program. So when you're writing a teleop program, you're going to want to use this while loop, like while off mode is active. So yeah, so basically the way it works is you just set the test motor, you set the power to the gamepad's right joystick Y. So basically what this means is it's like, yeah, what this means is if you look at the camera, it's like if you do like it's like this is the right joystick. So it's like the up and down. So let's say this is up is -1. So this would be running. If I did this, the motor would run at a speed of like -1. And if I did this, it would run at a speed of 1. So yeah, so that's what that is. And then here I have like an if statement. So if you press the A button on the gamepad, it'll set the servo position to 1. And if you press the B button, it'll set it to 0. So yeah. All right, I'll move on to the next slide. All right, so yeah, this is.
Before you move on to the next slide, so just want to stress on the importance of having while op mode is active, because if there is an issue with the program or code and you hit stop, you want to make sure that the program actually stops. And that will happen only if you have this while op mode is active. Otherwise, you may be stuck in a loop or stuck in a program and not be able to come out of that program. So please make sure you always have while op mode is active in your program.
All right, so yeah, all right. So moving on to the next slide, this is coding a touch sensor to move a motor. So this is basically, it's pretty similar to like we have the while off mode is active slide loop again. And then so now if you look up here, we created a touch sensor object. And then here we like we put it in the hardware map. So we just did like hardware map dot touch sensor dot get, and we did this. And in this while off mode is active loop, we have if test touch sensor dot is pressed. So basically, if the touch sensor is pressed, this will return true, which means that like this, whatever's in this if statement will be run. So basically, if it's pressed, the motor will be set at 50% power. And the else means like if it's not pressed, then the motor power will be 0. So it's off. So basically, when you press the touch sensor, it'll spin the motor. Yeah, so then next slide is really similar. It's the same thing except with the distance sensor. So the distance, I created a distance sensor object here. And then here I put it in the hardware map. And the hardware map for this is a little bit different. You have to do like hardware map dot get, and then you have to have parentheses, and you do like distance sensor dot class, comma, and then like your distance sensor name. So yeah, it's slightly different. It's kind of weird, but yeah. And then we have a while off mode is active. Yeah, we have a while off mode is active loop again. And this if statement basically says that if the distance sensor's distance. Oh yeah, and also all right, in this method, like test distance sensor dot get distance, you have to specify the unit. So centimeters is like the most commonly used unit. So that's what we're using here. So what this means is if the distance is less than 10 centimeters, then it'll set the motor power to 50%. Otherwise, the motor power will be 0. Yeah. And then, all right, yeah, next is coding a tank drive base. So this is all like this is pretty important. This is like, once you do this, you'll be able to have like a robot that can move around. So that's a pretty big step. So for this, basically, I just created like 4 motor objects: right front motor, left front motor, right rear motor, and left rear motor. This is kind of like the most common way to name your drive motors, because it's like really easy to distinguish which one is which. So yeah, so and then this also uses the gamepad again. We'll need to use the gamepad for this. Yeah, so all right, then then I have them all set up in the hardware map. And if you scroll or look down, there's to the while off mode is active loop. In here, we basically just set. Oh, okay, all right. So first I have to talk about one thing. So this is like there's a lot of different ways to code your drive base. So this is probably the easiest, most basic way. But basically the way it'll work is if you guys look at the camera at the gamepad, so this joystick, like the up and down, controls the left side of the robot, and this controls the right side of the robot. So like basically if I push both forward, then the robot will move forward. If I push both back, the robot will move backwards. And if I push this one forward and this one backwards, then the robot will turn this way, or turn to the right. So it's like, it's a pretty intuitive way to drive the robot, and it's also very easy to code. So that's the way this works. And so basically, if you look here in the while off mode is active loop, the right motors, so like, yeah, the first 2, they're both the right side motors. So they're set to right stick Y. And then the left side motors are set to like negative left stick Y. This is just because like it's like the right side and the left side, the motors are inverted. So the values you need to like, so like if you want, when you push the joysticks forward, if you want both sides to go forward, one of the sides needs to be negated. So in this situation, it was just the left side. Yeah. All right. So that's the first way to code a tank drive base. All right. Now the second way is a little bit more complex, but still pretty easy. So the way this would work is if you guys look at the camera again, with the gamepad. So this joystick controls forward and backward, and this one controls turning. So this way is actually a bit like, you'll have a bit more finer control and it's a bit easier to drive the robot like this. But it's slightly more difficult to code. Yeah, so, yeah, so to code this, it's basically, yeah, we have our motor objects, and in the while off mode is active, basically, your left stick Y, that's like your forward and backwards movement. So that's what, their left stick Y is in like all four of them. And then your right stick X, that's your turning movement. So basically what this means is like the right front motor dot set power is like left stick Y minus right stick X. That's because if you're going forward and you want to turn right, so if you on the gamepad, if you move the joystick to the right, that's considered positive. So if that means if we wanted to turn right, our right side wheels would have to move slower than the left side wheels. So yeah, if you kind of think about that, like let's say you're going forward and you want to turn right, your left side wheels would move faster and your right side wheels would move slower. That's why we subtract the right stick X for the right side wheels, and we add right stick X for the left side wheels. Yeah. All right. So now I'll move on to the next thing. This is like gets fairly more complex because this gets into coding a mecanum drive base. So if you guys don't know what a mecanum drive base is, we're getting like an example here. So if you see this, if you see these wheels, they look a lot different, right? They have like kind of rollers on them. So basically what this allows them to do is it allows the robot to move like side to side diagonally in any direction without turning. So this adds like, you can kind of see like the robot. You can kind of see the robot like can move side to side, like diagonal and stuff. So so this like makes your robot much more maneuverable on the field. So it's probably like the most popular kind of chassis or drive base, but it is significantly harder to code. Yeah, so but I'll show you guys how to do it. So basically, everything is the same except if you look here. So we have our like left stick Y. So okay, all right. Let me first tell you guys the way this like works with the gamepad. So basically, this left joystick controls like which way the robot moves. So like this is forward, this would be side of the robot would just like move sideways without turning. And like you could do diagonal too. And this joystick just controls turning. Yeah, so basically the code is like the same as the one from the previous program, except there's one more step added, which is the like diagonal strafing movement. So basically for that, that's like the left stick X. So the way I'm not going to get super deep into this, but like, because of the way a mecanum drive base works, we have to subtract the left stick X from the right front motor and then also subtract it from the left rear motor. So basically, if you think about it, those are like the two diagonal motors. So it's like, so the right front motor is like the right side like front motor, and the left rear is the left side like rear motor. So those two are kind of like diagonal from each other. So yeah, so for those two, you have to subtract the left stick X, and for the other two, you have to add left stick X. Yeah. All right, so now I'll move on. All right, so this is where it gets like kind of significantly more advanced. This is like machine learning. So if you guys don't know, in this year's game, we had this like little cone here, and if you see, it has little dots on each side. So there's 1 dot, 2 dots, and 3 dots. And so at the beginning of autonomous, you had to this cone was like placed right in front of your robot, and you had to detect which side was facing you. So basically, like one of the 3 sides would be facing your robot, and you had to know which side it was. And based on that, you had to do something in your autonomous routine a little bit differently. So that's where machine learning comes in. Because you have to use a camera to look at that code and then see, and then like, use it like through code, like you should be able to know what, which side is facing you. So yeah, so I'll just talk about machine learning a little bit first. Yeah, so machine learning is a branch of artificial intelligence and computer science, which focuses on the use of data and algorithms to imitate the way humans learn and gradually improve its accuracy. So yeah, so that's kind of where the AI comes in, because it's like a machine learning model. When you're training it, it's kind of like how a human learns. So it gets progressively better and better, like the more it trains. So it's like kind of like practice makes perfect. It's that kind of thinking. Yeah. And in traditional programming, complex rules are added to the computer program, and those are used to analyze input data and output an answer. And as an example, if the input data is an image of a flower, and if the programming rules can recognize the flower, then the answer flower is output. To enable a traditional program to recognize the differences between multiple kinds of flowers, it would require significantly more complex programming. So this is kind of what we're doing, because we have 3 different sides and it has to recognize which side it's facing. So that's, yeah, so that's pretty similar to what we're doing.
So, yeah, so basically, since you have to recognize 3 different objects or 3 different kinds of pictures, if you were doing this with traditional programming, you would have to add 3 times the set of complex rules. And the more variation you add, the more complex the rules will get. So it almost quickly becomes impossible to accommodate all the possibilities or being able to recognize all kinds of flowers. And that's where you need to move away from the traditional way of programming, and you want to go into leveraging machine learning models. And so what they've done here is given you the ability to use a machine learning model and use that model in your program to recognize whether you're looking at the bulbs or the lightning bolts or the other third picture. So machine learning focuses on providing examples to a machine learning algorithm or model and providing both data and answers. So you're basically telling it what a picture contains. So that way it is able to build its own rules based on the information that you've provided. And the rules keep getting more and more accurate, and they're built into the model, so that even if there's a variation in the input that you're providing, it will still be able to recognize that, what you had indicated it is, because you already gave it a bunch of variations and told it what that data really represents. And this is why here you're moving all the complexity into the algorithm that is generating the model, instead of having code which is always trying to identify every single kind of flower there can be. And by training a model over successive steps, you're going on improving its accuracy in identifying, especially something that was not previously shown to it. And that's, like Ron said, that's where the artificial intelligence comes in, because you are adding or giving it the ability to recognize something you hadn't necessarily shown before while creating the model. But because the model was able to generate the rules, it now has the ability to recognize this new variation, which it had not seen before.
All right. So so that's what traditional programs do. So instead, machine learning focuses on providing example. Oh, okay. Like next slide. Okay, all right, yeah, moving on to the next slide. All right, so TensorFlow. TensorFlow. So in first tech challenge, the machine learning platform used is TensorFlow. TensorFlow is an open source platform for machine learning with a good set of tools, libraries, and resources to enable developers to create tools such as the FTC machine learning tool, which is like, it's a tool that you use to create like your own custom models. So yeah, so TensorFlow has been utilized in FTC for a number of years, and it allows teams to recognize individual game pieces and clusters of game pieces via pre-built models developed by FTC engineers. But now FTC is empowering teams to build their own custom models with the FTC machine learning tool. So yeah.
Next.
Okay, that's yeah. All right. So yeah, you guys have listened to like a lot of information in the past like 3 hours today and yesterday 3 hours. So 6 hours in total, and like it was just like kind of constant talking. So you guys like definitely do not remember everything you have heard. So that's why we have all these links and references. So when we share this slideshow with you guys can like look at all of these, because this is like kind of like how where we learned like a lot of this stuff, and it just has like a lot of information, these websites. So yes, there's 2 pages of this. Yeah.
So both as mentors as well as team members, please remember that, you have these recordings available, of course, but you have 3 weeks left for the season, and you have access to all these resources. These are some of the best resources you will have access to. So please get through as much of it as you can before your season starts, so that you're ensured to have a good season. And I know this camp was geared towards rookie team members who might already know Java and want to use Java with Android Studio, or veteran team members who might want to move from block coding to Java Android Studio.
Yeah. So Vihan, did you raise your hand because you have a question?
Yeah. So can you send these to me?
Yeah,
Yes.
we will be sending this the recordings and slideshow out to you
Okay.
guys.
So
Okay,
yesterday's
thanks.
yesterday's recording was shared with everyone already. Today's recording, as well as the complete slideshow, will be shared with everyone via the same email address.
Okay.
So I know we went through a lot here, especially in the end, we quickly went through. So if you look at the second page here, you will have access to the resources that will allow you to, work with the machine learning model and things like that. So please make sure that you read this machine learning and TensorFlow in FTC, as well as TensorFlow in 2022-23. So if you read this, you'll have enough information to use the machine learning model and accomplish some of those really awesome tasks in the autonomous part of the competition. If anyone has questions, please go ahead and ask now. Okay. And to add to that, I know this is a lot of information that was provided to you. We hope that you're able to utilize a lot of it, and it makes for a really a successful season for everyone who are here in person, as well as everyone who's meeting with us remotely. So thank you, everyone. And thank you to all the members of Future Martians who are here and helped make this camp happen. So let's give a hand to all the people who made this happen. Okay. Thank you so much. And yes, please expect to get the second recording and everything else. Okay.
All right. Bye,
Have a great
everybody.
season.
Thank you.
Bye.
Have a good season.